All right, we will go ahead and get started. Welcome everyone to Advanced Kentucky's first AP Statistics Content Review session for the 2020-21 school year. My name is Aaron Timmons. I'm the Math Content Director for Advanced Kentucky, and we are happy to be joined today by Kristy Tinelli, who will be our first presenter from Bullitt East High School. She's a longtime successful statistics teacher, and we are glad to have her. So let me go ahead and go through some housekeeping here, and we will go ahead and get started momentarily. So as you can see on the shared screen, make sure you have today's handouts, bit.ly/mathcrs. Next. Just a disclaimer, this online review session is intended for a Kentucky audience. Space permitting, we welcome from students from across the country. I recognize a lot of familiar names, but I also know that we have a lot of people from around the country here, so we are glad you can join us. We will do all we can to provide every student with an equitable opportunity to learn. During the session, we encourage participation, and just know that any participant causing a disruption will be removed. So contact information for Advanced Kentucky is on the screen right there. Please give us a follow on Twitter. Look us up on Facebook. We'll be happy to share information with you via those means. Also, my email if you have any follow-up questions about today's session, and also my Twitter handle. I'll post announcements and reminders and things like that throughout the year. And Kristy, do you have a Twitter handle? Do you want to share? I don't know.
I don't have a Twitter, no.
Okay. All right, so today's etiquette, you are muted and your videos are off. I really don't think you can have the ability to turn those on, so I don't think you have to worry about that. We are going to ask that you fully utilize the chat options though. So make sure you can find the chat button at the bottom of your Zoom screen. You can chat directly with myself or Kristy, I think. But I would recommend if you have questions to send those directly to me, because then I can get those to Kristy while she's presenting and she can get your questions answered. So I know we have teachers here, I know we have students here, so any questions are fair game. We will throw those out to her and give you the best responses that we can. And then some of you have asked, teachers that have students that may not be able to join live, where will a recording be of the session? So the same site that you used to register for today's session, which was bit.ly/advky, we will post a video of today's session there shortly after we conclude, and that will be true for all other sessions. And then as a reminder, we also are offering content review sessions for all AP Math subjects. So that would be calculus, computer science, tools, and A, as well as the science courses. So that would be biology, chemistry, physics, and environmental science. And then later on this school year, we will have some English review sessions as well. So please make sure you are checking out the website there, because we have a calendar of upcoming events. So all of those Zoom links for registrations will be there. Those will all be free of charge. And we have some very strong presenters in store. So Kristy's a really great person to kick us off, and we will keep the momentum going throughout the school year. All right, so with that said, I'm going to stop sharing, and I'm going to turn things over to Kristy. She can introduce herself, give you all a little bit of a background on her. And again, if you have specific questions, feel free to shoot those to me in the chat. So Kristy, take it away.
Okay, well, welcome guys. I'm excited that there are so many people here. I see there's already 65 in here, which is awesome. So on a Saturday, snowy morning, at least where I am from. So I actually teach at Bullitt East High School, which is just south of Louisville. And I've been teaching for 16 years here. I think this is probably my 6th or 7th year teaching AP Stats, and it's actually my favorite subject. I also teach pre-cal, and I've taught other things over the years. I was an engineer, a chemical engineer prior to this for about 7 years before I started teaching. So I have a little bit of experience like in the real world too, you know? So, but I love stats. I love how you can apply it to the real world, and it's probably the easiest math class to do that with. So I am excited. Thank you, Aaron, for inviting me to do this. It's been an interesting year for us. My school personally, we've only been in person for 4 days, and we're finally getting ready to go back in person next week. So I know that all of you all are probably all over the place with what you have learned and the style that you've learned in. So I think these review sessions are really good, sometimes just to hear from somebody else, as well as go back and practice old things. And I know with my students in particular, I struggle so hard with trying to keep them up to date on content because it's easy to get behind this year, that we really haven't got to practice a lot of like real AP exam free response questions and how the scoring of that. So that's some of my intention today, is not only just review, but really practice the free response and like what to do, what not to do, how you're going to get the best score, and how it is scored if you're not aware of that. So please chat with me, anything you all have, comments, questions, any question that I put on the screen, if it's something like, hey, go ahead and put an answer in there, let's see what everybody's getting. I would really appreciate that because I can't see you all. So right now I'm only talking to myself. So any conversation is great. If you something that you may have been taught a little bit different that you want to share with everybody, that's awesome too. And other teachers, I know there's some teachers on here. So again, just please feel free to share with me anything that you all see. Okay, let me make sure. I think we're good on here. As far as
your screen, yep.
You can see my screen. Okay, and I just have, if you have paper, obviously you're not going to be submitting anything today, but just a few things to jot down. If you have the PDF that I shared open, you can, but you don't have to. It's the exact same thing you're going to see on my screen. If some of you all may have had access to print it beforehand, that's great too. And like I said, just chat anytime. So the first unit that we're going to be going over today for about the next, probably about 45 minutes before we take a break, is descriptive statistics. So that's what you started with in August, probably. That is all about one variable statistics. So when you all went through and just learned, hey, when I have a list of data, what can I do with it? What kind of visual pictures can I make? And then what kind of numerical analysis can I do? So that's what this first unit is all about. So it's way back to August. The first thing that I have is just sort of a comparison, because when you learned it, you probably learned the difference between quantitative and categorical. Those are the two different types of one variable statistics you learned about. Can you guys throw in the chat box for me an example of a one variable quantitative data? Awesome. Julie said height. And actually, I always say height too. Age and height, great. I always start with height for some reason. We all tend to, So what's on my screen there? Yeah, number of children. And what you all are actually saying, we've got some people that are telling me discrete variables and some that are telling me continuous. And this shows up again later when you talk about random variables, but discrete would be anything that's countable. So like, what are some counting? Number of children, there we go, somebody said that. And then continuous is anything that you can have decimals in between, basically. So what can we do with quantitative variables when you put them in a graph? And these are the four that you basically studied. There's some other more complex things, but this is what you studied when we first introduced one variable quantitative variables. Numerical analysis we can do. This is all of, okay, so I have a list of data, might be 20 data points or it might be 100. What can I do to sort of summarize that with numbers? So we started talking about mean, median, and mode, and that goes all the way back to 7th grade. But then we got into some more advanced things like standard deviation and so forth. Know that measures of center are either mean and median, and you started learning maybe when you should use one or versus the other and how to compare those two. Measures of spread, standard deviation, IQR, or range. And then location measurements, this is what we would make like a box plot or 5-number summary. And when you moved on to the next unit, you started doing z-scores and percentiles. Okay, when you see distributions, so sometimes it's a matter of just looking at the numerical analysis, like that 5-number summary, or something visual, like any of these. They are guaranteed 100% of the time in a free response question to ask you to describe the distribution. So just wondering, and actually before I ask this next question, can you guys tell me like what schools you all are from? Because let me just get a little sample here. What schools, because I know you all are all over the state, and we we get kind of, okay, so all over the place. And being in COVID right now, we don't get out much anymore. So I like to see where everybody's from. And you all really are from all over. Thank you all. All right, so knowing that you are in Florida, goodness, that's awesome. Knowing that you all are from all over, I know the acronym that we use here at Bullitt East, and I think it's kind of used quite often. What acronym do you all use, or do you use an acronym to remind yourself how to describe a distribution? Okay, so Julie said G-SOCS, and then I'm seeing socks and socks and socks with an extra S. And I'm just wondering, Julie, was the G, because I don't know what that is the G a typo, or is it, oh, okay, it's gaps. She said gaps. So that's good. So yeah, everybody seems to be using socks as well, and some add an extra letter in there. And that's what I put in here. So we want shape, center, spread, outliers. And then just at the bottom, I put anything unusual. Those would be your gaps and clusters. Hey, Charlie, what's your W stand for? Did you mean that? Or Carly? Sorry, I read it wrong. What's your W stand for? She's probably typing, so I'll give her a second. And a lot of you all said, okay, V for variability. Good. So that's for a lot of people, we just use spread there. But whatever works for you all. And the big thing to remember, the number one on this, no matter what letters you use, is context. So if you get all this other good stuff, but you forget context, you're going to be marked down on your free response from an E to a P for that part, okay? So that's real good review stuff there. For categorical, we don't spend as much time on it right now because quantitative is so big and there's so much to do with quantitative. So just for the sake of time, I'm going to kind of run through these a little bit faster. So categorical are going to be things that they might ask you where you can give multiple answers and it's not quantitative. So like what's your eye color, gender, even just yes/no questions. All right. So what can we do with things like that as far as a data display? They sort of mention circle graphs, but we very rarely see them. Mostly you're going to see these other things listed. So bar graphs or stack bar graphs and so forth. Okay, the numerical analysis that we can do with that, we can either put counts, which is frequency, in like a table or a list. Relative frequency means your percents or your proportions. And if we have two-way tables, we can start looking at these other types of distributions, or like if we see them in a bar graph or a stack bar graph. Okay, and then when you describe those distributions, don't use socks. It does not apply, right? So we just really start having to use some logic and some common sense when you describe categorical data. Look for things that occur the most or the least. You just, again, kind of common sense, but make sure you sort of thoroughly describe things. All right, so we are going to, actually, I've got another list of sort of important review stuff. I say things like you're almost always guaranteed. And I say this because I'm really, like, I love statistics and I love numbers. So I feel like I've looked at every AP Stats exam that ever existed for the last 20 years. And I feel like almost every single time there's an outlier check on there somewhere, either between multiple choice or free response. So just know it for sure, memorize it, and know how to use it quickly where you don't have to think about it. So your outlier check, the one they use a lot, is the 1.5 Iqr rule. I sort of type it up like this for my students, that the allowed min, once you figure out 1.5 times your IQR, you take it away from Q1, that's your allowed minimum. Anything lower than that is considered an outlier, and then other way for an allowed max, Q3 plus it. Okay, be very familiar, and all these things I'm listing again are just, you see them like every time on an AP exam. Be very familiar with comparing mean and median, when to use which one, that kind of stuff. That's what this next box is. It says, if the distribution is symmetric, the mean and median are going to be very close, if not equal. So if it's perfectly symmetric, they're going to be equal. And then when you started learning, so what if it's skewed in one direction or another? So your mean is always pulled in the direction of the skewness. So if it's right skewed, it's pulled that way. If it's left skewed, the mean is pulled the other way. The next thing I said is, so if you do have, oh wait, the next thing it says, if you do know that they're unequal, okay, so let's say it says the mean is higher than the median, what do you know? It does not guarantee the shape is skewed. So so this sentence right here, the second sentence, it's true going this way. So if we know it's skewed, we know for sure the mean's bigger, but it's not true going the other way. And the reason what I'm saying here is, let's say the mean, it says it's actually larger. We could have some funny distribution like this, all right? So it doesn't necessarily guarantee that the distribution is skewed. However, if we know the distribution is skewed, right skewed, we know the mean is bigger. So just kind of like a little thing to watch that they might try to trick you with. When you have symmetrical data, we want to use the mean and standard deviation to describe it. And then when we have skewed data, you want to use the median and the IQR to describe it. And the range can be used for either. All right, so again, those are all things that are sort of almost guaranteed at some point that you'll see it or need to use it. Also, an interpretation of standard deviation, you're going to see almost guaranteed. What do you all have for me? Let's type in the chat box there. A good way to interpret, what are some words for interpreting the standard deviation? Okay, so again, like if I said the average height is 60 inches and the standard deviation is 2. Yeah, there you go. So you guys are saying some good words, and I know you don't want to type a full sentence in this chat box, right? But it is, you all are getting it. It's the average distance from the mean. So how far each of your data points is from the mean on average. And instead of saying on average, you can also say the word typical. So memorizing that definition is super important because no matter where you are currently in AP Stats, you're going to see that standard deviation keeps popping up over and over. You're going to do the standard deviation of sampling distribution and standard deviation for two proportion, the difference of two proportions and so on. And standard deviation, the description is always the same. You just got to put it to the context that fits. So they will always ask you standard deviation, no matter if they're talking about unit 1 stuff or unit 7 or whatever. They're going to ask you to interpret it at least some point. Variance doesn't really have a context to it or an interpretation, but you do need to know that it's standard deviation squared or vice versa. So if they give you one, you could figure out the other or vice versa. Okay, yeah, and I hope you all just saw what Aaron said. He said, feel free, you can chat privately with me or Aaron if you want to ask a question or just throw something out you're unsure of, if you're unsure of your answer. Okay, and then the last thing is linear transformations. So what this means, I don't know what example you all were introduced when you were introduced this in class, but for me, it was height. We always refer back to height because that's something you're familiar with and you can just understand. So for me, it was like, we have everybody's height. What happens if everybody stands on a box? Okay, so we want to add 10 inches to everybody's height. So what changes here? So let's try the chat box again. If I want to add 10 inches to the height, the question is, does the centers change and or do the spreads change? Okay, so if I want to add 10 inches, what changes? Okay, you all are awesome. Center only. So it's the idea of if I had a distribution that looks like this and I want to just add 10 inches, it's just now over here. It's really going back to what you learned in Algebra 1, in Geometry, Algebra 2, and Pre-Cal. So if I just have a graph and I pick it up and slide it, right? So just the center changes, not the spread. And then what happens if then I want to convert everybody's height to centimeters? So I need to multiply. Okay, what changes when I need to multiply by 2.54? Okay, so what's going to change? Great. So I got center and spread. So all measures of center change and all measures of spread change. And that's what I put like as a little summary. The idea here, I forgot my daughter's slime, because sometimes I have it like slime, like you have this shape. I'm going to slide it over, but I'm also going to like stretch it out because I'm multiplying everybody by 2.54. So that spread, really, I'm going to spread that out. Now, if I divide, it's going to squish it in. So I change the spread again. Spread is standard deviation, IQR, and range. All right, so let's try some free response questions. I'm hoping, no way for me to know who's seen what free response question. Has anybody already seen this one before? River X, Y, and Z from 2010. I know my class hasn't. Okay, nobody's really saying yes so far, so that's awesome. So again, almost guaranteed, in one of your 6 free response questions, you're going to have something about descriptive statistics, and very likely it's going to have you describe the data. This particular one, so let me give you some free response advice first off. Some people sort of run out of time and on their free response. So you do need to budget your time. You get 90 minutes for 6 free response questions. Question number 6 is the longest. It's an investigative task. So practice is important, but in general, maybe spend 12 to 15 minutes on questions 1 through 5, and then your remaining time on question 6. Question 6 is longer. It's also weighted more. When you get to question 6, and later study sessions will probably focus on this, you'll see that the intention there is, you know, a little bit of the stuff, but a whole bunch of it you've never seen before. So it's like, what can you do with new material? Can you apply new material? So it is harder. You want to try to budget a little extra time for it because it's weighted more. So anyways, that being said, I only have, say, 12 minutes to work on this, right? So some people get really hung up in these long paragraphs here. And they start like, what's, you know, thinking, oh heck, what is aldrin and pesticides, and trying to make sense of it. A lot of times with my kids, I say, well, my suggestion is go right to what the question is and kind of scan through these questions real quick and figure out, do I really need the context of all this paragraph? Sometimes you do, so you need to go back and actually read it, and a lot of times you don't. So, you know, if I just scan through these questions, the first thing says, compare the distributions. Okay, my context is I need to know that it's talking about aldrin, but other than that, I don't really need the rest of that paragraph. Question number 2 says, make a stem plot. Again, I don't really need to know context there. I need to know I'm talking about aldrin, but that's it. And then question 3 says, tell me something that you see in the stem plot that you don't see in the box plot. Okay, so back up here, it doesn't matter that it's the 90s. It doesn't matter about pesticide, any of this stuff. What might be important possibly is that it does tell me there's 20 locations for each one of these. So each one of these, it's n equals 20. That might be important, but other than that, don't get too hung up on the paragraphs. Okay, so question number 1, the first one, A. We want to compare. Would you guys, I'm not going to have you all do the whole paragraph because that, again, we don't want to spend 10 minutes on this whole problem, but what's something that you could compare? Just tell me one comparison that you see that would jump out with you. Okay, and go ahead and like say a little bit more specific than just the word. Tell me something that you see that's obvious as a comparison. All right, I'm seeing river X is right skewed. The medians of Y and Z are close. Z has a small spread, good. X is larger range, good. Things like this. Awesome. River X has the most variability. That's a good statement there. Okay, so let's go with what the answer is. I'm going to tell you how it's scored, because how it's scored is really the key here. It's not just, do you know the right answer in your head, but you want to make sure, and the more you practice this, is you kind of like anticipate what the rubric is going to say Because if you know what the rubric is going to say, it's going to help your mind focus on what do I need to say in my answer so that I can be concise and precise and get done as quick as possible with it. So the key here is the answer. It's a pretty long paragraph, but we're back to knowing we need to do SOCs, right? So we need to do SOCs. We need context always. And you probably need the word distribution in there at some point. So you can arrange these sentences any way you want, but very key is don't just say the center of river X is about 5.1. The center, or the median even, the median of Y is about 5, and the median of Z is about 4.2. You're going to get a P for that. Okay, if you haven't done a free response yet, every part you're given an E, P, or I. E is basically for excellent. It's really for I don't know what I can't remember what E even stands for now. I call it excellent. P is for partial, and I is for incomplete, basically. Exemplary. Okay. So if you just list SOCs and you just list data about it, even if you have context, you're going to get a P. Because what's important is this thing right here that I'm going to highlight. I've got written all over my screen, compare. We have to have comparison words. So you have to say things like, the center of X is higher than Y, which is higher than Z, something like that. It even says in the rubric, you don't have to say specific values. So you don't even have to say 5.1 or 5.2 or whatever. You need comparison words. So let me clear some of these things off. Comparison words like higher than, right? Most variability, somebody said that. Largest range, those are really good comparison words. I kind of struggle with the shape of these because they say on this that X tends to be right skewed. I agree with that. And what you're looking for there when you're looking at a box plot, because those are a little bit harder to analyze than a histogram. You want to sort of compare these little whiskers out here. They seem to be equal, right? And then compare this to this. So the size of this box is bigger than this one. So if I had to draw like a corresponding box plot, to me, it probably looks something like this. Maybe not exactly, but something like that. Okay. So actually, I didn't really draw that right. I'm sorry. This is much more spread out. So it's more like this, I would say. Okay. So the tails seem to be equal, but sort of your middle is spread out. So they say that X is skewed right, Y is skewed left, and Y is roughly symmetrical. So these pieces are basically equal. And then it says that Z is skewed to the left. It is a little bit if you compare the size of those two little middle parts of the box. All right. So anyways, hopefully you've only spent 4 minutes on that question. Here's how you get scored, and that's key. And we'll start moving a little bit faster after this first one. So it says to get an E for this, we need context always, as long as you mention context at least once. So I have to say the words concentration of Aldrin in rivers at least once, and I get a check mark for that. I need center, spread, and shape. There are no outliers. There are no strange things like gaps and clusters that I can't see them anyways. But you do have to have comparison words. Now, if I do 2 of the 3 of those things, so if I have context and values, I'm going to get a P. If I talk about center, shape, and spread, and I say comparison words, but I don't ever say context, I'm going to get a P. So that's kind of how this rubric looks. And then it says an I is not an E or a P. Okay, so this particular question has 3 parts. We've only done part 1. As it turns out on this rubric, this part A counts 2 times what the other 2 parts count. So if you get a P here, you technically got a P twice, okay? So just kind of keep that in mind of what you think you might have got. And let's move on to part B. So part B, it gives us river X, and it gives us the data points specifically. So we want to make a stem plot. I'm going to go ahead and show you the stem plot for the sake of time. I feel like you all can probably make it. Remember, our leaves for a stem plot need to be single digits. So I'm going to do things like this 3 is going to be here, and I'll put the 4 here, you know, and I got a 4.0, and just kind of arrange things like that and start marking things off, right? Okay, what am I missing if I do this? If I go through all of this, but I'm missing something. Say my stem plot's right when I get done. It's a very important part of a stem plot. Very good. You all are saying it. It's a key. The key is right here. You don't have to have this title. It's nice if you do. It looks pretty. But that key is very important, because without it, I don't know if I'm looking at this and the concentration is 34 or 34,000. So I need that key right there. Your scoring is very easy on this. If you have the stem plot and the key, you get an E. It actually said on this particular rubric that units are not necessary, but I like them. You know, why not be nice and thorough? If you mess your stem plot up just a little bit, they'll still give you a P as long as you have a key. If you have the stem plot but no key, you're going to get a P. All right, so let's move on. The last thing is, it says describe something that you see in the distribution in the stem plot that you can't see in the box plot. So I've just copied these images so you all can see them again. All right, tell me something that you all see. And we don't need a big long paragraph for this. A sentence or two will do, so don't spend too much time. Okay, I'm seeing some answers. Good. I'm just waiting to see like some more things. Good. So bimodal, gap, there's nothing in the 6 range. Good. All these things are good. The key here and the answer is you need to talk about that gap right there. Okay. Let me tell you some things that you can say for full credit and things that won't quite get you the full credit, because this one's kind of tricky. And a lot of times part C is a little tricky to be precise and actually get an E for it. So it says the stem plot shows a gap, just like you all said, and it says where it occurs. Okay, so it basically is telling me I have no data points between 5.6 and 7.3. Let me check this chat box again. Okay, so you all are saying it. Somebody said specifically that you can't see specific values. That is true, but that won't give you the points for this part. Okay, so they want our eyes to focus on that gap right there. And the thing is, to get an E, you need to recognize the gap, right? And you also have to say where it occurs. So don't just say there is a gap that I can't see in the box plot. You have to specifically say where it occurs. Or you can mention that it's bimodal, but then you also basically have to talk about where the clusters are occurring. So that's the only way you can get a P. So, I mean an E, sorry. So to get a P, you might say the word gap or bimodal, but if you don't indicate where it's at, you're going to get a P. And then lastly, we're going to get an I. All right, now to sort of finish up this free response question. So you got 4 letters, right? So let's say you got an E for part 1. Well, that counts for 2. And then you got a P, and then you got a P, right? So we're going to add up some points here. Anytime you get an E, it's worth 1. Anytime you get a P, it's worth a half. And actually, let's change this last one to an I, because you just totally screwed it up. And you got a 0 there. Okay, so E's are worth 1, P's are worth a half, and I's are worth 0, and you add up your points. So I got a 2.5. Well, that's not what they're actually going to score you on, because they only score whole numbers there. So they're going to round you up or round you down. I've heard different things. I'm not a scorer for the AP exams. I'm going to see if we have feedback from any teachers, because I've heard both things. I've heard some people say if you get a half, they always round you down. And then I read things like if you get a half, they do a holistic approach and they kind of look at your whole answers and they kind of decide if they like you or not and if they're going to round you up or down. So maybe if you were real, precise and like labeling things real good and that kind of stuff, they round you up. I don't know. Be on the safe side and don't go for halves. because I'm afraid maybe they're just in a bad mood and they're going to round you down to a 2. But that is how it's scored.
I know we've got Dr. Sherry McGuffin in here, who's an AP Stats reader, so hopefully she will give us her input on that.
Yeah, and I know we kind of get delayed speaking sometimes, so sometimes there's a break just trying to wait for responses. But I've heard both. And so what I always tell my, okay, so she said it's a holistic approach. Does it feel like a 2 or a 3? So when you go back and look at all these parts, do you feel like this student is really knowing what they're talking about, and are they being thorough, and then do they understand this real, you know, the problem here and everything that, you know, we're trying to get at? So I like to be on the safe side and just go for whole numbers, and then you don't have to worry about it. Are they going to round you up or down? So anyways, that is free response question number 1. Let me check my time here. All right, so we're going to do another free response question because I want you to see something totally different. This one had to do with one variable, quantitative data, and we went through the process of looking at describing the shape, but not only describing it, comparing. So I pulled this one out because if it's just one where you got to describe it, we're not practicing using our comparison words. So I wanted to pull this one out because if you can compare words, I know you can do just one distribution. And then looking at other things like, hey, what's different in our different types of graphs that we do? So what do you see in a box plot versus what do you see in a stem and leaf plot? Sometimes one is better, sometimes the other is better. So what are sort of the benefits of both of those? Okay, so the next free response question. Now, if you were to flip to this while taking the exam, you're probably going to look at this and say, oh my gosh, there's so many words here. There's so many graphs. I'm a little overwhelmed. So again, for the sake of time, you want to sort of budget probably around 12 minutes for this. It's okay if you go up to about 15. Some of you work faster on certain things. Just realize that, you know, there is a time factor, 90 minutes total. My students, at least, typically don't run into time issues. I usually only have 1 or 2 per each year that have time issues. And it's usually the kids that write too much. It's not that they don't know what's going on. They have so much in their head and they are very proud, and they should be. They feel like they want to say everything that they know so that the grader knows how smart they are. And sometimes that can be a problem because if you overwrite, and even though you might write about something that is not even the question, if you start saying things that are wrong, I hear that they'll grade you down, like they mark you down if you start saying things are wrong. So you want to stay concise, answer the question fully, and then move on. So this question here, you can see we have categorical data displayed in a two-way table. I might just sort of scan what this question entails so I can make an approach for it. So this question says calculate the proportion that are at least one extracurricular activity for on campus and off. So, you know, if I go back and read this prompt very quickly, it says that it was a large university, and basically I'm just pulled some people who live on campus and some that are off campus, and I'm kind of comparing how many extracurricular activities they're in. Okay, so the part A, we just need to do a proportion. And then part B says, write a few sentences about what we see here. So we see a categorical data displayed. What do you see? So I'm really going to get at what the correct answers are and what the rubric shows. And then part C says, I put on here, it has to do with inference. So you haven't learned that yet, you know, and that's typical on a free response question. It's not always stuck with just one unit. It's very typical that it's going to bounce around and pull from different units. So we can only do part A and part B so far. So part A, do I feel like you're pretty comfortable answering the question, what proportion of on-campus are at least one activity? Right, so it would be these people right here. They participate in 1 or 2 out of the total. Okay, so pretty easy question. What people are most likely going to do incorrectly is not show work. So even though this is super easy work, you're going to go right to your calculator and you're going to do 17 plus 7 over 33 and you're going to get that answer real quick. You have to show that work or you won't get full credit. So the answers in an example answer is to show that work. You can leave it like a fraction or a decimal. Make sure you're sort of clear which one is which. They wrote it in a sentence. That way they have context there. The scoring looks like this. If you get it correct, both answers on and off campus, and you show work, you'll get an E. The P is you got your answers correct, but no work. Half my students have that problem on these really easy proportion questions. You did, or variations of how you might get a P. All right, part B for this problem says, what would I do? I just need to compare. So it says write a few sentences. To me, that means 3 or more, but there's also not a lot to write about here. So I would probably just shoot for 3 sentences. Okay, what are some things that you all might say? It says, right, summarize what the graph reveals about the association. What's something that you all see here? Okay, so it's almost like this one is so easy. It's like kind of basic, right? But we have to just make sentences out of each individual thing. Yeah, I see some now. So on campus are more likely to participate. Good. So we start seeing, okay, no activities would be this. So off campus is more likely to not participate at all. We see that this is almost the same. So again, we want comparison words here. We want things like more than, less than, or about the same. Pretty easy. I'm going to uncover the answer. You don't have to use numeric values again. We want comparison words. So it says, if you compare proportions, this is what the actual rubric said, between 2 groups, so between on campus and off campus, for at least 2 categories, you would get an E. So you didn't even have to comment on all 3 categories, at least 2 categories. A P would be that you list the proportions, but you don't use comparison words, or that you only compare like 1 category or something like that. So we can't really finish this free response question because again, we can't move on to the inference. So far you would have got an E or a P, or you would have got 2 letters so far. The other 2 letters come from part C of this, which is the inference. Okay, so we are now going to move on to multiple choice. And I'm going to shoot for about 10 minutes, maybe a little bit more, because we can cut back on part 2 of this today. Let me go on to multiple choice. Okay, so on to multiple choice. On an AP Stats exam, you have, again, 90 minutes. There are 40 multiple choice questions. So that comes out to 2 minutes and 15 seconds on average per question. Obviously, some questions you're going to do a lot faster and some take a lot of time. You just have to know that what you're working with as far as a budget. My students tend to not have too much of a timing issue. It's not like the ACT where almost everybody has a timing issue. However, practicing is what's going to let you know if you have a time issue. Oh, the other thing I was going to say is free response and multiple choice are equally weighted. So they're 50-50 as far as your final grade. All right, next thing I said practice. Well, that's sort of obvious, but the reason for practicing is it's not only time, but it's also the more you practice multiple choice, the more you start to anticipate what the questions are. Sometimes you could glance at a question and know what they're asking before you even have to read the whole thing. The more you practice, the more you know ways that they're trying to trick you in multiple choice. And it's not really like they're trying to trick you to make you get it wrong, but there is precision in the wordings. So the more you practice, the more you know what precise wording to look for. The rest of this says things like, know your calculator. You're not going to use it a lot, so only use it when it's efficient. Your formula sheet, my students don't use the formula sheet a lot, but knowing what formulas are on there and which ones you're most likely to have to go reference occasionally and knowing it well and where it's located and then like the layout of the formula sheet is super helpful. That's a time saver. This is the one that some of my students really like is, and a lot of them say they do it. I don't know if you all do this too, but a lot of times people like just to skip to the end and read the question and then decide how much you need to go back and read context for. Because sometimes there's a really long prompt and a lot of stuff that's just a lot of fluff and you don't really need that information. And it's taking you a lot of time and your mind starts focusing on what the context is when it really needs to just be focusing on maybe comparing median and mean or something as easy as that. Go back and read context sometimes if you need it. Sometimes your answer choices, if you just sort of scan real quick, it gets your mind focused on how should you attack this problem. Again, that's a time saver. And then the last couple of things I said is anticipate keywords. And then the last thing, and we'll sort of practice this today, is don't think you can outsmart the test writer. All right, some people say things like, oh, all of the above, you know, if they have that, always pick it, or if it says none of these, pick it, or if it says not enough information, it's never that. Don't think it's an always or never on any of those things. I'm going to show you a couple of times that we can, you can't outsmart the test writer. They're smarter than you.
Kristy?
Yes.
Can you talk, someone asked a question about, do they get a formula sheet on the exam? So I know they do. Can you
Yes.
elaborate on that a little bit?
So, and if you all want to pull it up right now while I'm talking, so if you just Google AP formula sheet, AP stats formula sheet, the first thing that pops up is from the College Board. So that's the official one. And it changed this year. It surprised me when I pulled it up. I was like, whoa, what is this? It is different. It's got the same stuff on it, but it is different than the years past for the last, I don't know, 15 years. I don't know for sure, but it is organized the way you learn it. So descriptive statistics are at the top. It gives you the formula for mean and standard deviation. You're pretty much not ever going to look at that, you know. Next couple formulas, there's 4 for this. Well, no, for linear regression, which is what I'm going to do next. There's 4 formulas on that for that. So there's like, how do you calculate R value? You're not going to have to calculate that by hand, but it's on there. So if you want to know what plays a part in R value, like if you forgot, you can look at that formula sheet and say, oh, well, if X does this and Y does this, how it plays a part in R. Then it moves on into some probability formulas. Those are the first ones that some of my students need to refer to. It tells you intersection formula and a given that probability formula. And then from there, it random variable, binomial, geometric calculations, and then a whole bunch of it is all your inference formulas, which you do need to refer to from time to time, unless you have like a super good memory and can remember the setup of all those. But it goes in order. So formulas themselves are 2 pages long. Why don't I just pull it up, you know? You can see the last thing I tried to find the scoring guide for my gray wolves. So the first one that comes up from the College Board, like I said, is the official one. And if, again, knowing what you see in order and sort of what's on there and what's not is super important. So it's a time saver. Sometimes, you know, I ask kids if after they take the test, because I want to know, you know, I know what I would use, but I want to know what they use. And most of them say they very seldomly use it, that they only pull it out for like maybe a setup of one of these. And you all probably haven't got to inference yet, but some of these inference setups, that is very helpful that that's on there. But most of this first stuff, this is your mean and standard deviation that you're looking at. This next 4 are your linear regression formulas. We'll talk about that in the next hour. A couple of probability formulas. And then this is random variable stuff, if you all have got there yet. For me, it's chapter 6, and we just started that. And then, like I said, everything else beyond that is inference. Now, you are also provided tables. So you're provided 3 tables. It used to be 4. Table A, and also it was funny one year, somebody came back after the exam and said, oh, well, I couldn't, how was I supposed to know table A, blah, blah. And somebody said, well, it was in the back of the test booklet. And they didn't know that the tables were in the back. So yeah, it was like the formulas apparently are in the front. I've never seen the exam, and the tables are in the back. Table A is like your normal calculations. It's 2 pages long. And then table B is your T distributions. You probably haven't got to that yet. That's 1 page long, sorry. And then table C is your chi-squared distributions. I'm sure you haven't got there yet. And there used to be a table D of random integers, and it is no longer provided. And that, I'm sure that's because if they want you to use it, they'll just put a little clip of it on the actual test question. You don't have to flip back to the back of the book to see that. So that's what the formula sheet looks like. And yes, you're provided that. Okay. All right. And we'll refer to that a little bit more in the next hour. So let's look at these, right? So I'm going to try to save a little time. If it's okay, we might get a little close to 11 o'clock and then take maybe like a 7-minute break. That still gives us a solid 50 minutes for part 2, if that's okay. All right. So this first one, kind of long here, but let's go to the question first and then see what we need to go back and see in the prompt. Which of these is least likely to be used? So that kind of lets you know, and kind of scan through these answer choices, what's least likely to be used in this context. So now I do need to go back and read the context, but at least my mind's focused on what am I trying to read for. And when I see these answer choices, I know if I'm going to make a stem plot, this is all quantitative variables. What do you all see without even reading any of this? I don't know. My kids, my personal kids, missed out on Sesame Street, and I feel bad about that. But there used to be a thing of which one of these is not like the other. Some of the teachers probably know what I'm talking about. And it was like a screen, and there'd be people or whatever. Which one of these is not like the other? Which one of these options is not like the other? That you probably know the answer without even reading the question. Yes, a scatter plot. That is correct, because all of these are 1 variable statistics. Now, we have 2 distributions. That is why we might do back-to-back stem plot or parallel box plots or 2 histograms. But this is when you're trying to see an association. So we have 2 variable statistics at that point. So that is the answer. It's B. We can go back and read the context if you want to be certain, and I know many of you want to be certain that you're picking the right answer. But basically what it is we want to see if people that are friends with the mayor are getting better raises than the people who are not. So we would have a list of people who are friends with the neighbor, a big long list, and then people who aren't part of his political party, a long list of their numbers, and then we do something with it, okay? So yes, B is the answer, and I put on here, we're comparing, we aren't looking for an association. Okay, B, or number 2, I'm sorry. Number 2, there's not a big paragraph to read, so we don't have to worry about that. It's one of these questions that's a pain. This is one that you got to go through and do process of elimination. Only one of the things is true, which means 4 is false. And it is a bit of a pain. However, you still may be, if you feel really confident in yourself, you may be able to sort of quickly go through these and plan your attack and see if, do I really need to figure out the median for both of them, and then the range for both of them, and then the Q3 for both of them, okay? And for the sake of time, I'm going to look at what D says, because D is the answer. D says the mean of A is greater than B. Okay, let's look at the shapes here. We've got this shape and we have this shape. Okay, can you all see why, if I sort of highlight, that the mean of this green one is going to be bigger than the mean of this one? Just sort of visually looking at it, can you tell? This mean is going to be bigger. I think you probably can. Me, I feel like when I was in high school, I was a pretty I wanted to get the right answer. So I probably wouldn't have just picked D based on that alone. I probably would go back and confirm that all 4 of the other options are not true. But they do turn out to be not true. So I'll show you every one of them. If I went through and found the median, so we'll do just the median, and because I assume you all can do the rest. To get the median, we have to know that there's 16 data points. So the median is going to occur between the 8th and the 9th data point. So we're going to start counting this. Remember this stem plot going to the left? You got to read it this way. So this first data point is 126 and then 138, and read it like that. So there's data point 1, 2, 3, 4, 5, 6, 7, 8. So the median occurs between 192 and the next spot, which is 200. All right, so it occurs between the 8th and the 9th data point, and you'll get the average of that, which is 196. Okay, and then you got to do the same for company B. So if you were to go through and do all 4 of these options, you see that all 4 of them are in fact true. D is the thing, or false, sorry. D is the thing that is true. All right, but that is one of the pains because you got to go through basically all 5 options. All right, this one, now if the last question took you a lot of time, maybe 3 minutes, this one should be a fast question, like 30 seconds. So, or less maybe. Check out this one. Put for me in the chat box what you all think here. Good, you all are excellent. So everybody's saying B, perfect. So it is skewed to the right. One way to remember that when I first introduced it to my kids is like, if you're standing up here, here I am, which way would I ski? I would probably definitely ski this way. Otherwise I'm gonna fall to my death. So I'm gonna ski to the right. So we know we're gonna get rid of these 2 options. And we know that the mean is gonna be pulled in the direction of the skewness. So your mean is more in this direction than the median, which is what option B says. Very good. So you can almost feel certain for sure that that type of question is going to show up either in free response or multiple choice where you compare mean and median. Okay, we'll touch on that later. Okay, here's one about standard deviation. It says, which one has the largest standard deviation? Okay, so a thing about standard deviation, remember, it is how far on average each data point is. So we know the thing with probably the best standard deviation is this. This has the lowest standard deviation because everything's sort of closer to the middle. All right, so I'm gonna give you all a second. What do you all think has the biggest standard deviation, where we have more points furthest from the middle? Okay, good. I'm already seeing D there, and all of you all are right. So again, this might be a question that if you anticipate this kind of question, then you're going to get this in maybe 30 seconds, which gives you a lot more time for doing those ones that you got to go through all 5 answer choices. Okay, next one. Here again is one that I've got to go through all these answer choices. It says what can't be justified. So kind of like what's false, or what do we not have enough information for? So we would start going through all 5 of these answer choices, right? But instead of doing that, I would scan the options first and see if anything stands out for you before you actually start calculating things. There might be something that stands out as incorrect or can't be justified. It's D again, and I can't tell if you were saying D to the last problem or this problem, but it is D again. In a box plot, we don't know how many data points are in these 2 distributions unless it tells us. It might be 20 and it might be 1,000, and there's no way to know what they are or if they're equal, so we can't assume that, right? Then you could go back, and if you wanted, because you know you're one of those good students, which I appreciate, you would go back and maybe check that all those other ones are true, but it is definitely D that's false, or we don't have enough information for. This next one here, I'll go through this a little quickly on your calculations. We can anticipate an outlier question. So we see we have this summary data here, and we know for sure we need to use that rule of the 1.5 IQR. So I'm gonna go ahead and do it for you, and then let's see what you think the answer is, okay? So my allowed max and min, so again, I've figured out 1.5 times my IQR. I did Q1 minus it. This is my allowed minimum. And then I did Q3 plus it. If this were free response, you have to show your work. You don't have to show your work on multiple choice. So my allowed min is this, my allowed max is this. So how do I know how many outliers I have? Okay, let's go back up and look at our data. Our minimum point is 628. Do I have an outlier on that side? Yes, right? Okay, my maximum point is 1577. Do I have an outlier on that side? Yes. Okay, so what is my answer over here? It's either D or E, right? You all are all saying D again. It is, you all are correct. We don't know that it's exactly 2 because we don't know, you know, what all is occurring between 628 and Q1. We don't know how many, you know, data points are really small or whatever. So all we know for sure is there is at least 2, which is D. And then I'm going to skip. I feel like well, no, I better not skip this. This is important. A lot of people miss this. I've got 2 more I'm going to do real quick with you. We have a histogram. And okay, on this one, so it says they already did an outlier check and they determined that 93 is an outlier. So this data point that's right here, this little bar, this guy is an outlier. It says there's only one of them. Okay, so now it says, now that you know that, which one of these box plots is correct? So I start going with process of elimination. All of them are showing the little dot here for the outlier, so that's cool. The next thing we need to probably look at for process of elimination is where should your whisker go? If you call it a whisker, I don't know if you'll call it a whisker. So should the little whisker be all the way to here or should it only be to here? Okay, so we need to get rid of some of our options based on that. So does the whisker go up to like 85 or does it go up to like 62, right? That's what we need to be looking at. So here's how you know. Some people make this mistake and they think, well, if I'm getting rid of 93, there must be something here in the 80s. Well, there's not. We got to go all the way back here, right? And in a histogram, you don't know what value that is. All we know is it's somewhere between 60 and less than 70. So we'll call it between 60 and 69. So the next highest data point is between 60 and 69. So we're going to get rid of some options like this, right? So we're not going up to 80. We can get rid of all these options. We're only going up to 69. And then when you look at option C and D, we can see that the next thing you need to compare, the thing that is different about them, is where's the median? Is it, you know, roughly 15 or is it a little above 20? Okay, so that's a real good question because it makes you do a lot of things. So what it ends up being, we have to go and actually figure out the median. So luckily it tells us that there are 26 data points. So we know that the median needs to be between the 13th and the 14th data point. So I'm going to start counting how many occurrences I have. I need to get to the 13th data point. Well, there's 6 here and 4 here. So I'm not to the median yet. I got to go further. So my median occurs somewhere in this bar right here. We don't know where for sure it occurs, but we know that it occurs in that bar, which is between 20 and 29. So that means I'm going to pick option D. That's showing my median that's in the 20s, basically. Okay, that's a lot of analysis that you have to do on that question to get that, to get your answer. You know, that may be one that takes more than 2 minutes. So luckily you've banked some time on some of those other questions. The last one I want to show you is this one. And I thought it was important because I said, don't try to outsmart the test writer. So I have kids that do this. All right. Tell me if y'all do this. If you look at your answer choices, I have kids that say, oh, 357 is used 3 times. That must be the answer. Let's get rid of this. And then they say, oh, 20.1 was used twice. That must be the answer. And they pick A. Do you all know what I'm saying with that? Now, if I wrote the test as a teacher, that might be true. But your test writers are outsmarting you. So it's kind of like the game of they know that you know that they know that you know what might happen. So they're not going to let you play that game. Okay. You need to do the math on this. So this is a linear transformation. We have our mean and our standard deviation, and you all were really quick at telling me what to do with the mean and standard deviation when I do a transformation. We want to add 2 pounds, and I also need to do a correction, which is divide by 2.2. Okay, so it has a correction of minus in 2 pounds because it's 2 pounds too high, and then I also need to do a division process. So I wrote a lot of work out here. You don't have to write it all out, but I'll just show you what the answer is because I trust that you all can do it. We know that the center is going to get minus and divided, but the spread only gets divided. So notice how the answer is actually B. Okay, notice how standard deviation of 21 only showed up once. So you can't outsmart the test writer in that situation. All right, so that basically, I think, finishes descriptive statistics. I'm sorry I went over. We will take a break. Aaron, if you want to take over for a second and tell us how long, and then that'll leave us a solid like 45 minutes or something like that for linear regression.
Yeah, so again, thanks for all of you holding on to your attention for this first session. We'll take about, we'll resume about 11:15. How about that? Give you a chance to get up, stretch, get a drink of water or whatever. Kristy, do you plan to hang around here in case anybody has questions during this next little bit of a break?
Yeah, I can hang around. I need to get, it's hard talking this long, you know?
Yeah, so get yourselves a drink or whatever, and we will pick back up at 11:15. But if you have any questions in the interim that you'd like us to address at the top of the next session, go ahead and put those in the chat or send them directly to me, and we will address those right at the beginning here at 11:15 Eastern time. So we'll see you back then.
You guys, trust me, I know it is hard to sit here and listen to one person talk on the computer. I know it is. I have 3 kids of my own, and sometimes when I'm at home with them, I'm like, man, do I sound like that? Because I would put myself to sleep if I sounded like that. It's difficult. So you all are doing a great job this year since last March, adapting and, you know, still continuing to try to learn no matter what the situation. So I know it's hard. So thank you all for participating again. So we're moving on to linear regression. So what this is our 2 variable statistics where we are basically trying to see, and it's got to be quantitative again, so measurable like that. And we are typically trying to see if there is an association. Let me go ahead and skip to this page. Well, between your 2 variables. With my kids, my students, I let them pick 2 variables that they wanted to see if there's an association from and like gather their own data from the internet, not like go out in the traffic and gather data, but look things up on the internet. And they did all sorts of things. Like people chose, you know, sports oriented stuff. Like, do they want to see if there's an association between ERA in baseball? You baseball people know what that is. And if there's an association between their salary or, well, Olivia's on here. I never can think of what people did off the top of my, Olivia, what was yours? Do you remember? She did tuition versus graduation rate. So she wanted to see if there's specific colleges, what they charge for tuition, if there's an association with, is their rate of graduation associated with what the tuition. And she probably hypothesized that the more they start charge for tuition, the better their graduation rate is. And then after collecting that data, you can kind of see, is there in fact an association? Now, when you collect that data, first off, you would have it in a list and then you would make a scatter plot. So we started with how do you describe a scatter plot? So I'm interested with you all. Okay, don't say socks here because it's not socks. It's not one variable. Does anybody have an acronym for this? Because I don't. I've never really seen one to remember, an acronym to remember what to include in your description. I'm not seeing one pop up yet. So I always just say the words. It's direction, form, and strength. All right, so when you describe, you have to describe the direction, which is either positive or negative, the form, which you all only really know linear. So otherwise you would just say not linear or curved maybe. Higher stats class, you learn other types of regression. Strength. Seth, you'll have to say what that is. Okay, well, I can guess what that is. Duffs and scuffed. Okay. Strength and association. Oh, and you got to say the word association between, and say in context, always in context. Fads. Oh, there's so many. That's awesome. So I can guess what duffs and scuffed mean. Scuffed. Okay. What's the A? Form, direction, strength. So A is association, I'm guessing. Okay, form, association, direction, strength. Okay, well, cool. Whatever works for you all, but those are the things that need to be included. So it's 3 things in context, and always say the word association. And some of you all have O, which would be outliers if there happens to be outliers in it. Okay, so once you plot the graph and you see things, and you start describing, you can kind of say, oh, there's kind of an association here, or there's definitely not one. You can usually tell if there's not one. So when there is a little bit of evidence of an association, where do we go from there? We want to see that the scatter plot is linear. Then you also learn how to make a residual plot. So we'll go over that. In the residual plot, you want to make sure that there's no pattern. So we actually want it to be scattered and all over the place. And sometimes we start looking at some of our numerical analysis, which would be like the R value or R squared. And you kind of look for it to be close to 1. Now, none of these by itself is enough to know that we have a linear association. So you need supporting evidence from different places to come in to know that we actually have a linear association. So again, just seeing that an R value is close to 1 doesn't mean that your association is in fact linear or a strong linear association. So going on from there, always be careful and expect this. When you see problems that are linear regression, expect them to try to throw in something about causation. And anytime it says that, the answer is no. We do not know causation. So if we in fact see an association, that's all there is. You can kind of change the words association with correlation, but don't throw the word causation in there. So like with Olivia's project, when she did tuition rate and graduation rate, if she saw an association, she can't say that higher tuition causes a higher graduation rate, just simply that there's an association, so that there's a lot more coming into play that's actually causing kids to graduate at a higher rate. Okay, if you do in fact see a good association, you can use that line, and we call it the LSRL, least squares regression line. We can use that line or the equation of that line to predict Y based on X. And then you all learned a vocab word, which is important to know what it is and use it in a free response question if it comes up. The word extrapolation means if your data set falls in here, don't try to predict way outside of that range. That's what extrapolation would be. And then, I mean, this kind of goes along with residual plot. You need to know how to get a residual. Always remember that your actual minus your predicted is the difference. So we want to, if your actual is higher than what's predicted, you'll get a positive there. And if your actual is lower than predicted, you'll get a negative there. Okay, a little bit more about R value, which R is the correlation coefficient. A little bit about it. It's unitless. It's always going to be between -1 and 1, including both of those numbers. The closer it is to 1 or -1, the stronger your points are fitting a line. You sometimes run into questions that say, what happens to R if you do this? So what happens to R if you switch X and Y? Well, it doesn't change. The equation of your line is going to be its inverse function, so it will change, but the R value is going to be exactly the same. Or sometimes they might say, okay, what if you add 10 points to everybody's score? What happens to the R value? It, again, doesn't change. All right, so let's just jump into, oh, one more page, sorry about that. You are typically not going to be given a list of data and have to figure out the equation yourself. I may be wrong on this, but I'm saying typically on the AP exam, they're not going to ask that. And I think the reason why is because, you know, it takes you're spending the majority of your time typing in your calculator, and that's not really what, you know, the writers are wanting to do. They're wanting to know that you can analyze. So, and plus you can have some typos. So typically what's going to happen is they're either going to give you a regression screen, and I'm sorry you can't see this one very good. On later examples, you'll be able to see it. So you need to know where to pick out the important variables. Or they may give you this summary data right here. And this is the one that my students tend to forget how to do. Okay, they may say, what's the equation of the line? And they give you X bar, Y bar, S of X, blah, blah, blah. Okay, you're going to refer to your formula sheet for this. This is one of the few times that I would say, go to your formula sheet. Don't try to memorize this unless you're just good like that. And then last, on our quick review before we start trying some problems, is the difference between outliers and influential points. So outliers would be anything, let's say we have a little scatter plot that looks like this, anything that falls outside of most of your points in either the X direction or the Y direction, or the X and Y direction would be an outlier. An influential point is one that if you got rid of that point, it's going to change the slope of your line. So looking at the example I just drew, with it, my line might look, oh, I'm trying to draw with my mouse, so it's not very good. My line might look like that, but imagine if I drop it. So I just totally get rid of this. Aaron, am I showing on video, by the way?
Yeah, you're good.
Okay, so imagine if I just drop and get rid of that point altogether. My line is, you know, then I'm only looking at these points. So my line is suddenly looking something like that. Okay, so it drastically is changing that point, or what my line is, just disregarding that. So it becomes not only an outlier, but it is also an influential point. Okay, so we are going to jump into, I've shared this table with you guys. On this unit, some people really like this unit because if you could sort of get in your head that there are 5 variables that you need to know how to interpret, and you memorize these phrases, it can get you pretty far whenever you see a linear regression question, whether it's multiple choice or free response. It's not going to get you everything, but it's going to get you pretty far. So I shared with you all in the PDF this table. This is sort of a fill in the blank interpretation. And then what you need to know is, okay, so you're going to, if I'm interpreting the Y-intercept and my Y-intercept is 13, I'm going to say, so when X is 0, Y is 13. I can't say it like that. I got to make it be the context. Whatever X is, whatever Y is, and then put units of measure. So then I put an example over here that says like, okay, here's your Y-intercept 3.75. So when a team scores 0 points in a game, they're predicted to win 3.75. All right, and I just gave you examples. I'm not going to read all of these to you because you can read it. You've probably seen this. You may have forgot some of it, but knowing how to interpret all 5 of these is super important. On slope and even Y-intercept, you should add the phrase, and I added it later, and I realized I forgot, on average, or the word predicted, because it's not a guarantee. Our equation, again, is only predicting what's going to happen on average. So we should probably add that little phrase in there. Okay, so the first free response question, when you first see this, might look a little overwhelming. There is a lot going on here, okay? So they gave us on this free response question, this is about trains, all right? And it says they got 10 trains, and what they've recorded is how many rail cars that train had, and the fuel consumption, or basically gas mileage. In a way, it's gas mileage for 10 different trains that they saw. Okay, so they gave you the table. They went ahead and they gave you the scatter plot. They also gave you the residual plot. When you see that, make sure you sort of look at titles here so you know what you're looking at. So see, we have residual here. That's important you see that. And then lastly, they gave us the output screen. So we have every bit of information already done for us. So at this point, it's a whole lot of interpreting things in context and analyzing a few things, okay? So the first question says, I know there's a lot on this screen, so let me switch where you can actually see the first question. It says, is a linear model appropriate? All right, so I've included 3 pictures that you may look at. You probably wouldn't look at the table, so I've just copied 3 pictures. You may not need to look at all 3 of them, but I've put 3 on here that I know you probably might look at. So first off, let me just get in general an answer from you all. Would you say yes or no to this? Yes, no, or maybe? Well, you pretty much have to choose if it's yes or no. Okay, so I'm seeing yeses, yeses, yeses. Bunch of yeses, good. Okay, tell me something you might look at for evidence. Residual plot, good. And what I want to look at for there is I want no pattern, that I'll need to see at random. So you guys say that statement, right? Okay, what else might I look at? Because that in alone is not enough. Good. Kyle said that my LSRL is linear. I probably want to say, I know what you're saying here, but you probably want to say approximately linear. Actually, it's pretty good linear, you know. Your residual plot is centered at 0, good, with no pattern, good. You all have said exactly what we need as an answer. I'm going to uncover this. You all don't need to probably read the example. Let's go to what the scoring guide is looking for, because again, we need to know, am I going to get an E, P, or I on this? So to get an E, you have to say yes. Don't forget to say yes. Don't forget to actually answer the question. And then explain. Now, they only say we need to talk about the scatter plot and the residual plot, exactly like they did. Now, they never referred to any of my numbers like R or R squared in their reasoning here. You don't have to. A P would be that you said yes, and then you gave 1 evidence. Or that you gave the evidence, but you failed to say yes, something like that. Oh, I would be that you actually said yes. So like if you just said yes, it's good, but don't say anything else. You get no credit for that at all. So don't do that. And you can see the other specifics down there. So that is how you're going to get an E, P, or I. So we're going through this process like, how am I going to get my 4 letters? Hopefully you get E, E, E across the board, 4 of them. But we'll see, maybe you can think of what would you get on this. All right, on to part B. I'm going to give you all a second because this is a little tricky, maybe, I don't know, to tell me the answer here. You don't have to show your work, but this answer right here, I'm going to give you a second on it. Tell me if y'all can't see the screen well enough. It should be okay to pull out the information that you need. And, you know, this probably will take 30, 45 seconds. I don't know. I'll be quiet for a second. Oh, and Kenzie, I see your message. She said something about context for the last one. On that particular rubric, or for that part, it did not require context. Probably because in the other parts that we're getting ready to answer, some of those require context. I would probably be safe and do context. Let me think if I would do it on this one. I would probably do it on that one because you're going to say the phrase association, so I would probably do it. All right. Do we have, I feel like this one is pretty hard. The wording on this is kind of hard. Does anybody have a guess? You could do a direct message if you're not sure. What do you think? I forgot the answer, honestly. I know how to get it, but I forgot it. is okay, so I'm starting to see some answers. This one's pretty tricky, I feel like. And it has to do with, what's the question? Yeah, it's this one. It says, so we're trying to answer this, give a point estimate. You know, one thing that you need to sort of get straight in your mind are what are the units of measure? And I feel like that would help a lot with this. We are looking for the change in cost. Let me switch over to my slate here so I can write a little bit better. Okay, we want the change in cost of fuel per mile for each rail car. So we're wanting something like this. It's kind of weird, you know? So which number has to do with, okay, I'll get you all straight. So this 2.15, right? So let's put what units of measure this is. So it is the slope, 2.15, but let's go ahead and put units of measure, and I think it'll get you a little bit closer. What are my units of measure on slope for this particular problem? I'll even go back to the, like you can look here, maybe, that might help. Remember slope, even from Algebra 1, is always y over x. Okay, so it's always, your units on it are always y over x. So it's fuel consumption per rail car. Yeah, fuel consumption per car, right? So let's go ahead and interpret. He said my camera, I don't know why my camera keeps turning off. Let's go ahead and interpret slope, and then we'll see where we need to go from there, okay? So how do I interpret slope? I always say as x goes up by 1, as x increases by 1, y increases in this case by 2.15. Okay, that's my interpretation. Now let me put some units on it. As fuel consumption goes up by $1, I guess. Is it $1? No, it's one. What's it measured in? Units per mile. Here, I'm going to write, and this will make it all easier. As I increase cars by 1, my fuel consumption goes up by 2.15. Okay, that again is not actually what it's asking. So I'm going to give you all sort of like 2 ways that you might have figured this out. And it must have not saved. All right, what I can do is 2 things. I can say, well, what happens when there are 0 cars? What's my fuel consumption? And then how much does it cost? And then I can just do something like, okay, what if there's 1 car? What's my fuel consumption? And then how much does it cost? And I can see how much is that increase each time. So in my equation, what I would do is, here's my equation. Okay, so I could put a 0 in there and find out I'm going to use 10.7 rail cars, but then how much does it cost? That's not how much it costs. It costs $25 times that, right? So roughly whatever 10.7 is times $25. That's how much it's going to cost me. And then I could put 1 car in that and see how many rail cars it costs or takes. And then times 25 would tell me how much it's going to cost me. And I could see the increase from here to here. Now that's sort of like, if you're not understanding the units, like how to just do some transformations like that. So what's easier to do is all you've got to do is take your slope and multiply by 25, and we'll have our answer. So our slope, remember, is 2.15, and what it's measuring in, I keep forgetting the context here, is fuel per mile over rail cars. So it's fuel per mile over rail cars. And if I multiply by $25 per unit, I'll have what I need, which is $53. All right. So here's the answer. What we're really trying to get here on this scoring guide is you have to have your work shown like this simple multiply calculation and get $53. A whole bunch of people are going to say slope only because they know slope is rate of change, and they just forget to use the $25. Okay. And then not an E or a P. Now, don't get frightened. If you didn't like this question, don't think that part C and D are harder, because it's not always that A is the easiest and then it gradually gets harder. And don't assume that because you didn't get B that you can't get C or D, because that is definitely not the case. So you can guess what you would have got on this. A lot of people historically are going to get a P or an I. They can't get the units of measure quite right. So just think about what you would get, and then we're going to move on. Okay, so the next thing says interpret R squared. So this has nothing to do with whether you understood slope or not. So if you memorize those 5 phrases, R squared, I gotta move the chat box again, sorry, is right here. We always want to say, whatever it is, we're going to say it's the percent of variation in Y that is accounted for by the linear model that's trying to relate X to Y, something like that, okay? Here is their answer. And then I'll show you what you need for an E. Now, when we look at this output table, I should have sort of reviewed this because I'm not sure if everybody's clear. Constant means your A value. The next thing is your B. Luckily on this, they kind of almost gave us the equation at the top. So my equation is Y hat equals 10.7 plus 2.15x. Standard deviation of residuals is right here, and R squared is right here. We never look at R squared adjusted. You're currently not looking at any of these things. Now, as you move on to regression, linear regression, and inference, sorry, on linear regression, you're going to have to look at some of these things. So don't worry about it right now. So these are the only sort of 4 numbers we pull. If you need R, if we need the R value, remember, we're just going to take the square root of R squared. And remember that R could be plus or minus. So it's going to match the sign of the slope. So if your slope is positive, R is also positive. Okay, so back on this, how do we get an E? We have to say that phrase correctly, basically. And they're looking for various things. We want to say variation in Y. Remember, Y is fuel consumption. And you got to say using the LSRL to do what? Okay, so X is your explanatory, or you could say something like using rail cars to predict fuel consumption or something like that. P is simply, saying the correct phrase, but using the wrong number. So if you use this number right here, R squared adjusted. So even if you know that it's 97, but you don't say the phrase right at all, or anything close to the right phrase, you're just going to get an I. So it does not help just to know that R squared is 96.7. Okay, and then the last part of this question is D. It says, so I just want an answer from you guys. Would you say yes or no? And then we'll go through explain. Would it be reasonable to predict? Okay, so is it reasonable to use that equation to predict for 65 rail cars? Okay, and so right now it looks like I'm getting yeses and nos, and it's about even. And you guys that are saying extrapolation, perfect. Anticipate that and know that you need to use that word, or at least the idea. Now, if you use the word, you're good to go. If you use the idea, you've got to really explain yourself. So it's interesting on this one. So we want to use 65 for X. So we're thinking about this right here, right? So we want to look at all these X's, and is 65 like a reasonable number to use if these were my if this was my list of inputs to create the equation? Is 65 reasonable or not? You could even go back to the graph right here and think about my graph went this far. Could I go all the way out to 65, which is about right here? Okay, So is it safe to predict all the way up here? So it's interesting on this scoring. I'm going to skip right down to the scoring of it. It says you can say unreasonable due to extrapolation. You can say unreasonable, but have a very weak explanation. Or if you say reasonable because it's only slightly outside of the range, you would get a P. So you're not really wrong if you say no, or you say yes, it's safe because it's only slightly outside the range, but you would only get a P there. Okay, if you say yes, you can use it, but then you talk about R, why R is good, or you talk about why the residual plot is good or something like that, you're going to get a P on that. All right, so again, for this, that was 4 parts. So just imagine if I got, let's say I was pretty good on the first part because I knew how to, I forgot the first part now. Was that describe? Oh, it's why can I use it? So you got an E, and then maybe you didn't like part 2, which a lot of people don't. So you got an I, and then maybe a P and an E, something like that. So again, this is 2.5 points. What if you got something like that? This is 1 point, 0 points, and halves. So your overall score is a 2 out of 4. Okay. All right. So let's look at the second. Actually, let me see what the second one is, and we might go to multiple choice and come back.
Can I ask you a question?
Yeah.
So in your experience, is a 2 a good score?
Okay, so we can talk about that. Like when you all take the mock exam, and I'm assuming all of, or most of you all are at least, you get to kind of see how your scores play out. And that's a good question. I almost talked about that, but I didn't want to take time, but I think it is very important. So thank you, Aaron. So we will put your scores based on what you get on multiple choice and what you get on free response in a calculator, right? And it spits out what you would have most likely got on the overall AP exam. In general, and it changes year to year because you all know how things are normalized now. So the scale sort of changes year to year based on your peers, like how everybody else did for that year. But I think the calculator that we most recently used, Aaron, was a 44% was a 3, which is passing. Trying to remember the next cutoff. I know it was somewhere around a 70 was a cutoff for 5, and then I forgot the 4. Okay, so in general, a 50% is actually a good score. You don't want to shoot for 50% because then you might get 40% or less. You know, you want to, if you come out of it thinking, hey, I got about 70% of that right, then you should feel pretty darn comfortable that you're going to get a 3, which is considered passing at most colleges. So don't feel like you have to get like a B or something like that. I know if we talk about it like a 44%, that's a really bad F, but that's not really an F. That's not how this AP exam scoring works. So I tell my kids, hey, if you're getting half of the multiple choice right, and you're getting 2s consistently on your free response, you can feel somewhat confident that you're going to pass. I would like you to get the 2s up to 3s, or at least some of them. So the more you practice and you see those little small mistakes that can get you up to a 3 on those instead of a 2, you know, you're creating some safe zone for you. Again, you don't want to shoot for a 50, but if you get a 50, you're most likely going to pass. Okay, does that sort of help you all know? I don't remember the cutoff for a 4, but you know, the distribution of AP scores is very symmetrical. It is very much 1s, 2s, 3s, 4s, and 5s like this, okay? You can't get a 0 on it. On a free response question, it gets a little confusing. Free response questions range from a 0 to a 4. Your AP exam final score, once you average in multiple choice, ranges from a 1 to a 5. 3 is considered passing at most colleges. If you haven't really looked into it yet, you can Google the phrase, will my AP score count at a college, like just that in general, and it brings you to a College Board page. that lets you choose what college you want to go to, and then it gives you a summary of every AP exam and what the score required is, and specifically what class at that college it covers. So it's very thorough. If you don't know what college you're going to, you can just click on like AP Stats, and you can see all these various colleges listed. I mean, it's great. So my students have found out, and I didn't know this my first year, that at some colleges, if you get a 4, you get 2 math credits for it, which is awesome, you know? So not only are you, I mean, you're getting 6 college hours for this one class. And it's specific on what classes it covers. But anyways, you just have to look specifically at your class. Now, if you go to more of like a prestigious school, maybe it takes a 4 or a 5 to get college credit for it, but you can look into those, okay? So if you get a score of a 2, you're not a failure. A 2 is actually reasonable and average. So, you know, I'm sure you all want to be more than average, but don't feel bad if you're getting 2s, especially on your practice test, because you'll get better and you'll start getting those up to 3s and 4s. I always tell kids on question number 6, because it's weighted heavier, if you can get anything other than a 0, it helps a lot. It's a hard question. So people that get 2s on that, they do all kinds of analysis on this. People that can get a 2 on question number 6 are highly likely to pass the overall exam. So a 2 on that is actually really good. So anyways.
And then just a quick point that for everyone in Kentucky, it's state law mandate that any public university in Kentucky will offer credit for any AP score of a 3 or higher. So regardless of the class. So not just stats. But,
does that mean sometimes it's an elective?
It could be a math credit. It could be an elective credit. It could be, it's however the college, but the colleges do have to award some sort of credit for an AP score.
Okay, so this last one for pre-response. Oh, we're running out of time. Big time. Let's skip to some multiple choice. You guys, if you have the PDF and you do want to practice, you can just Google this. And you saw in my Google box I did AP Stats Free Response Gray Wolf's Scoring Guide, and it'll pull up the answers to this. I'll tell you how to get an EP or I. It's very easy to sort of follow this, and it's really good for practice. I wanted to skip to some multiple choice. So we do have time for that, and my tips are the same. All right, let's try. I think this one is important because my students forget this. We'll do that second. Trying to get some good. Okay, let's do number 4 first. So it's the one on the top of my screen showing. And Aaron said that on this one, he's going to do a poll and you can put in the right answer. I don't know how this works. He's going to help me out here. So go ahead.
I said, take some time and read the question, and then I'm going to launch the poll, and it'll pop up on your screen, and you can drag and move the screen to your side if it's taking up too much space. But go ahead, take 30 seconds, read the question, come up with an answer, and then there will be an option for you to select your choice without having to put it in the chat here in a second. All right, so I'm going to click the launch poll. So these are anonymous, so you don't have to worry about putting your answer associated to your name in the chat, but go ahead and select your letter. And then after everybody's got their response in, we'll share the results to see which one was the most selected. And again, you can drag the screen to the side if you can't see the question anymore. You can drag that window.
Okay, so we're getting some good responses. Thank you. That's a lot of participation already in a short amount of time. And you can see, you know, what others are saying here.
There are the results.
Okay, and so let's talk about this. So this is good to practice this. The question is, what's the residual? So we have our prediction equation. We have an X and we have a Y. So what most people are doing wrong, and I would anticipate this, is that you possibly are only figuring out your prediction. And so if you picked B, which is what most people did, you only figured out what is the predicted Y, but you forgot to go back and figure out the residual. So it's actually not B, okay? So it's a good one to practice, and I know for sure that this kind of question will show up, okay? So what do we need to do to get the right answer? Because we're not there yet. So we need the residual, right? So the residual is the difference of your Y actual and your Y predicted. Now on this problem, we can't subtract the wrong way because we don't have negatives as any answer choice. But remember, we want to go through and figure out Y actual was 7. My Y hat was 3.78. So my residual is 3.22, which is A. Okay, does that make sense and correct some issues there? Hopefully. Okay. Residual is very common. It was also in my second free response. Part C, I think, was a residual question. So make sure you remember that formula. It's not on the formula sheet, but it's something you got to put in your head, okay? All right, let's try. This question is also residual. So let's try, that one's also residual. Okay, let's try this one. This is a good one. It says, basically interpret slope. Okay, and so since we had a little trouble with the slope question before, I think this is a good one to try also. Do you want to start the polling question for this one,
Sure.
Aaron?
All right, so again, if that screen popped up in front of your award, just drag that screen or drag that window off to the side.
Okay, and I'm going to help you get started. The slope is negative 1.71. We see that from the equation. You do need to know what X is and what Y is in context. So you're going to have to scan through and see that X is number of years and Y is degrees of motion. And remember, slope is always Y over X. So we're dealing with degrees over number of years, something like that. Okay, so I always would jot that down before I try to interpret.
All right, we'll go ahead and end the polling.
Okay, and you all have done really well on, you're somewhere between D and E for the most part. And I would agree that that is the best, that's the best, the closest. So again, I would always, what I'm circling up here in the top right corner, I would write down, I know it's always Y over X as far as my units. So it's degrees over number of years. And you want to start with, as X goes up by 1, Y, in this case, is going down by 1.71. So then when I read through my options, the only one that are anywhere close are D and E. So we want to say decrease there because Y is decreasing. I've got too many chat boxes open. I can't see my answers. And E is going to be the better choice because it's estimated decrease. Okay, it's not, this one kind of indicates that it's exactly 1.71. It's actually estimating that the decrease is 1.71. Okay, so E is the better answer, although D and E sound very, very close there. So you got to read for precision. And then I will do the last one because I think it's important. It's actually the second one on this paper. This is where you would go to the formula sheet. So it says we want the LSRL to figure out the slope. So we don't need the whole equation, but we need the slope of the equation. So somewhere, kind of get in your mind, if they ever ask you and they're giving you these 5 pieces of information, I want to go to my formula sheet and know that it's there. So when I look at the formula sheet, here's a little snippet of the top of the formula sheet. This is what you're going to use to solve. So this is the form of your equation, a plus bx. B is figured out by doing this, and A can be figured out right here. Okay, so if I need the whole equation, I have to start by getting the slope. And then if I want the whole equation, I'm going to once I get the slope, I can plug it in here, and I know x bar and y bar, and I can get A. And then I'll have my whole equation. Okay, so Aaron, if you want to start the poll again, we need to use basically only this bottom formula to figure out the slope here.
Will do. And Kristy, your camera went off again. If you
so weird.
That's okay.
Okay, so I know we're running out of time, and I see we already have like 20 responses, so I'll go ahead and talk about this one. Pretty much most everybody got B for B, B for B, which is slope. Yes, it is fairly simple. We want to use that part of the formula sheet. Let me delete some things here. This part right here is going to tell you the slope. Now, most people aren't going to remember that because you very rarely have to do it, but know that it's there on your formula sheet. We're just going to plug those 3 numbers in and get 1.556. Now, if you had to know the whole equation, then you would plug in 1.556 in for B. And we also know x bar, y bar, and we could solve for A, which is your Y-intercept. So I see this type of question, not every year. So occasionally, like 1 out of every 3 years or something like that. So just be aware that it is on the formula sheet and that you might need to refer to that, okay? So that, we don't have time for these other multiple choice, but a lot of them have to do with residual. And then one of them had to do with, like this one is what percent is explained, blah. Okay, so we're looking at R squared. So you can look at these questions on the PDF if you want to give them a shot, give them a try for more practice. And like I said, the one free response question. All right. So thank you personally for you all participating and being with me online today. And then Aaron, do you want to finish up?
Yeah, please. I've just got one screen to share.
Okay.
All right. So again, just a couple of things to wrap up. Thank you very much, Kristy. I thought you did an excellent job. If you have questions, follow-ups for either Kristy or myself, please reach out to us. If you are working some of those multiple choice questions in the handouts and you want to check your answers, you can shoot an email, and I'm sure she will let you know if you are on the right track or if you've gotten the correct answers or not. So her email is there. Again, my email, and along with Twitter and our website, is all on that screen there. Handouts and recordings for today's session will be posted at the bit.ly/ADVKY website. The handouts are at the Math CRS, but they can all be pretty easily. If you have questions, comments, concerns, suggestions for improvement, shoot those emails to me. I'll be happy to take those into consideration. We want to make it as useful to you as possible. Our next stats session is February 13th. It'll cover experimental design and probability, 2 of the topics in AP Stats that you may have covered so far, and we'll be joined by Dan Kim from Louisville Male High School, so we'll be excited to have him as well. So again, Kristy, thank you so much. If any of you have other questions, you can stick them in the chat right now, and we'll hang on for a little bit, but if not, enjoy the rest of your day, and we'll see you soon.